Hello students, welcome to lecture 5 of the solid state. In the last class we have completed number of atoms per unit cell in a different type of cubic unit cells. We found that in simple cubic unit cell 8 into 1 by 1. In BCC body centered cubic unit cell 8 into 1 by 8 plus 1 into 1, that is 2. And face centered cubic unit cell 8 into 1 by 8 plus 6 into 1 by 2, 1 plus 3 equals to 4. That part we have completed. I have drawn diagram also and I have explained how the simple cubic unit cell has 8 corners, 6 faces, 12 edges, and there are 6 face centered atoms, 1 body center atom, 12 edge center atoms. There is a face diagonal, there is a body diagonal. All this part we have completed. Now in today's class we will solve some questions regarding this, exactly this type of questions you can see in the MCQs. So question number 1 is, there is a compound crystallization cubic arrangement in which P atoms occupy the corners of cube. P atoms occupy the corners of cube. The corners of the cube and Q atoms are present at face center. What is the formula of the compound? What is the formula of compound? Now when such type of question asked in theory also it can be asked. It can be only of 1 mark. In MCQs also we know that depending on it is 4 mark, in KCT it is 1 mark. But thing is that we have to make one table here. In first we will mention the type of atoms present, which is P and Q here. In next we will mention their location or their position. We can say that P atoms are at corners and Q atoms are present at face center. Then you write their number. If they are present at corners, they are 8 in number. If they are present at face center, it is 6. They will write their contribution. The contribution of those particles, those atoms which are present at corner is 1 by 8 because it is shared equally in 8 unit cells. Those which are at face center, half. Then we can calculate the formula. The formula is, there are 8 atoms and they are present 1 by 8 part in a unit cell. So that equals to 1. And there are 6 atoms and their contribution is 1 by 2. So that equals to 3. That's why you can say that formula is it's not A, it is P, that doesn't matter, and it is Q and it is 3. So PQ3 is the formula of this particular compound, of which the description is given in the question. Now the next question is very simple. You can calculate this within 1 minute if you know procedure. Now the next question is question number 2 is A atoms occupy corners and B occupy face center. One of the corner unit cell remains vacant. There is this new thing here. A atoms occupy the corners. B atoms occupy face centers. B atoms occupy face centers of unit cell, of course, of unit cell. And what they mention here, one of the corner in each unit cell remain vacant. One of the corner in each unit cell remains vacant. What is formula? What is formula of compound? So A and B are the atoms here. A and B are the atoms here. A and B. A is present at corner and B is present at face center. But their number is one of the corner remains vacant. This is 7. But face center there is no vacancy. All are occupied. So this is contribution is 1 by 8. Contribution is 1 by 2. The formula will now change. It will be instead of 8 into 1 by 8, 7 atoms, and their contribution is 1 by 8, and it is 6 by 2. So we can write this A and B, and we can write 7 by 8, and this is 3. We can simplify this by multiplying with 8. So we can write 7 by 8 multiplied by 8. But as we are multiplying A by 8, B also should be proportionately multiplied by 8. 3 into 8. Why we have multiplied by 8? So that this will get cancelled. So it becomes 7 and this becomes 24. We cannot simplify them further. If we are able to do that, we have to do it. For example, 7 and this is 21. We can say 1 is to 3, but there is no possibility in this particular question. So we can write A 7 and B 24. This is the formula of that particular compound. Right, so this is question number 2. These are all simple questions. I hope that you are understanding these questions. Then we'll go for third question. The third question is like this. Atoms Y at each corner and atom X is at the centers of alternate faces, right? Or they have said anions Y and ions Y. It doesn't matter for us whether they are atoms or anions, our treatment should be same. At each corner, and cations X at centers of alternate faces of unit cell. What is simplest formula? What is simplest formula? So for this question, we'll just modify this all information. These are not atoms, these are ions. And there is a X and there is a Y. Right. So we'll just complete this information. Because this should be the pattern in which we should solve it. X are present at alternate phase centers. Alternate phase centers. So what we mean by alternate phase centers? This is the diagram I am drawing here. If it is present here, it cannot be present here, but it will be present here. Alternate. This is vacant. This is vacant. This also should be vacant because they are present alternate phase center. Right. Now this is also alternate only. The front and rear. How they are alternate? If they are present at top, this is alternate phase, and this is also alternate phase, which is to be remain vacant. Front has to remain vacant. And then at bottom, when we have water, rear also should be vacant, because rear is also alternate to the bottom. You are understanding? Because it is three-dimensional arrangement. If present at top, this should be vacant, that should be vacant. Means to the right should be vacant, to the left should be vacant, to the front should be vacant, and to the rear should be vacant. Because all these are alternate faces to top. But bottom is not alternate face, because we have left this 1, 2, 3 and 4 faces vacant. So we can keep it at bottom. And once we put at bottom, the rear is the next one to bottom. That's why it also should be vacant, isn't it? So it should be present only at top and bottom. Left and right should be vacant, as well as the front and rear also should be vacant. This means cross means vacant. So we can say that there are only two in number, this alternate phase centers. This Y is present at corner, and there is no missing part here, so they are 8 in number. The contribution is 1 by 2. The contribution is 1 by 8. And we can say that 2 multiplied by 1 by 2 is 1. And 8 multiplied by 1 by 8 is also equal to 1. When we write the formula, we should write cation first. So it is X. 1 means no need to write it. Y is also 1. So formula is just X by. Yes, try to understand this. Very simple concept it is. Then we will go to the next question. The atoms A in the next question. We'll take more questions so that every possibility is covered in the question. You can see that every question is different. So that's the way we should solve the questions. Now we are dealing with fourth question. The fourth question is the atoms A are present. Atoms A are present on the corners as well as phase centers, as well as face centers. Atoms B are present on its center as well as body center, as well as body centers. What is formula? What is formula of the compound? What is formula of the compound? So once again we are dealing with atoms A and B. So this I write atoms. Locations are two here. So atoms are A and B. Locations are there. So alternatively you have to change that. So there are two locations of A and two locations of B. One location is corner, another location is face center for A, and for B, one location is its center and another is body center. The corners 8, face center 6, 8 center 12, body center 1. This already we know it, isn't it? Contribution is 1 by 8 for corner, 1 by 2 for face center, 1 by 4 for 8 center, and 1 for body center. So it is 8 into 1 by 8, 6 into 1 by 2, 12 into 1 by 4, 1 into 1. That equals to 1, 3, 3, 1. So, what is the contribution of A here? A is 1 plus 3 equals to 4, and B is 3 plus 1 equals to 4, isn't it? A is also 4 and B is also 4. So what we should say here? A 4, B 4, divide by 4. So it must be AB should be the formula of this particular compound, right? So this is question number 4. Quickly we will go to question number 5. Yes, you just complete this because locations are 2, so we calculated accordingly. If you are thinking that speed is more, you can just pause this video and write it, and when I write the question you try to solve it by your own, because these are not at all difficult questions once you understand the concept. It is just only mathematical calculations. So now the next one is, next question is, atoms of A occupy corners. Atoms A occupy corners. Atoms B occupy each face center atoms of A missing from two corners. Atoms of A are missing from two corners. What is corner? What is simplest formula? So we can keep this table as it is because we are having A and B only. I think exactly similar type of question we have solved in question number 2. It is just different situation here. And we will see what can be answered here. The location of A is corner and that of B is face center, and atoms of A are missing from two corners means they are 6 in number, but face centers as it is 6. Contribution is 1 by 8, 1 by 2. 6 into 1 by 8 equals to 2 by 3, and 6 into 1 by 2 equals to 3 here. So the situation is here that A is 2 by 3 and B is 3. It should be multiplied by 3. 2 by 3 multiplied by 3. This also should be multiplied by same number. Otherwise we will get wrong calculation. This will cancel. So this is A2 and it will be B. It is 3 by, sorry, it is 3 by 4, isn't it? It is 3 by 4, right? Extremely sorry, it is 3 by 4. And that's why our answer will be not like that. But I hope that you got the correct answer. 3 by 4 and this is 3. This 3 by 4 has to be multiplied by 3, and that's why B also has to be multiplied. Sorry, this is to be multiplied by 4 and this also should be multiplied by 4, and that's why we got this 4 cancel. So we have A, B, B simplified, isn't it? So we can write this as A, B, 4. That would be the correct form, isn't it? A, B, 4 would be the correct answer here, because 3 and 12 can again simplify it in this way. So this is question number 5, and we'll have one more type of question like this, and then I may give you one homework. We'll see how we'll go further. So next question, which is question number 6 now, is calculate number of atoms. Number of atoms in cubic based unit cell. Cubic based unit cell having one atom on each corner. On each corner and 2 atoms on each body diagram. So we can say that contribution of atoms at corners 8 into 1 by 8 equals to 1, and contribution of atoms at body diagonal, 2 atoms, and they are present on each body diagonal. So you can say 2 multiplied by 4, that equals to 8. So you can say number of atoms in unit cell 1 plus 8 equals to 9. This is the answer for all this description which is given in the question. So this is question number 6. Now we can have question number 7. In a cubic unit cell, A atoms are at corners. A atoms are at all corners. B atoms are at face centers. B atoms are at face centers. C atoms are at its center, and D atoms are at body center. Number A, there are 5 parts of this question, so that every concept will be clear. If you solve this one question carefully, all this type of MCQs you are able to solve. A is calculate formula of unit cell. Calculate formula of unit cell. So you can do it yourself. So this is homework. A, B, C, D. Corner, face center, edge center, body center. 8 at corner, 6 at face center, 12 at edge center, 1 at body center. Contribution of A 1 by 8, B 1 by 6, C 1 by 4, D 1. Accordingly, you can calculate that answer. I will write answer here so that you can verify. This is just type of questions we will solve it. Only here items are 4, A, B, C, D, but that you should not worry about it. The formula is A, B 3, C 3, D. This is the answer. This you can solve it as homework. Now part B will solve together. If 25% A, 50% B and 75% C are removed. Calculate formula. So these many items we are removing. A we have removed, B we have removed, C we have removed, and D is not removed here. So A, B, C and D. Now how many they should be present initially? Let's make this type of problem. Present, they are before removing. A is at corner, so 8, B is at face center, so 6, C is at edge center, so 12, D is at body center, so 1. Now how they have removed it? They have removed 75% of 8. Sorry, 25% of A. 50% of B and 75% of C, and they are not removed any from D. So this is present, initially present, removed is this much. This is 1 by 4, 8 by 4 is 2 has been removed. This is 2, 6 by 2 is 3. This is 3 by 4 and 4 is 4 3s are 12. So 9 they are removed. So present is now 8 minus 2 because they have been removed it. So it is 6. 6 minus 3 is 3. 12 minus 9, 3. And this is present as 1. We can write contribution. Contribution. 6 into 1 by 8, 3 into 1 by 2, 3 into 1 by 4, because particles which are present at the center have been shared in 4 units, say, and this 1 into 1. So this we can write 2 3s are 4 and 2 4s are 8. This is 3 by 4 or 3 by 2. This is 3 by 2 and this is 1. Right, these numbers we are getting here. So A is 3 by 4, B is 3 by 2, C is 3 by 4 and D is 1. Multiplied by 4. Multiply by 4. 4 4 get cancelled. 3. Multiply by 4. 4 by 2 is 2, so it is 6. Multiply by 4 is 3. And this is D 1. Isn't it? Because that has been not removed completely. So what we can get formula here is A3, B6, C3, and for D we get it as 1 only. We cannot simplify it further by dividing 3 as 1, 2, 1, then this will be half. No need to do that. This is the correct formula. This would be our correct answer, right? Now the situation C, part C of the question. You should write this. You have to pause video and then write, because I have to make space. The question is going to be very lengthy, next part also. So I will draw this part now. Initially present, removed, present, contribution, formula. In this way we have solved it. And how many are removed? 25%, 50%, 75%. Of what? 25% of 8, 50% of 6, 75% of 12. 9 have been removed, 3. 3 have been removed, 3. 2 have been removed, 6. And their contribution. So, not at all difficult. But when the suddenly percentage are used, you may think that this is a difficult question, but it's not difficult if you understand the question carefully. Now C is, if all atoms present on one face are removed. So this is A, B, and C is, yes, C is different situation. C is, if all atoms along edge is removed. If all atoms along edge is removed. So for that we write A, B, C and D. How many of A are present? 8, 6, 12, 1. Now, if all the atoms of H are removed, I will draw that diagram. Of course, I will draw a very small diagram, but you can understand. Along the edge has been removed. On the edge there is one atom here, and there is atom there. So two corners are to be removed out, and one edge center, which is aspect center C, has to be removed. There is no atoms involved in face center, which is B here. So there is no need to remove it. Get removed from B, as well as no atom of D also have been removed. So it also has to be 0. So it is 6, 6, 11 and 1 is the formula for this. Then we can write the contribution. This is contribution. 1 by 8. B is at face center, so 1 by 2. C is at edge center, so 1 by 4. And this is 1. So in case of formula, 6 into 1 by 8, 6 into 1 by 2, 11 by 4, and this is 1 by 1. This we can write just as 11 into 1 by 4, because that's how we written like this. So this is nothing but, again we can say 3 by 4, 3, 11 by 4 and 1. So what we are getting here is A, B, C, D. A is 3 by 4, 3, 11 by 4, 1. Multiply by 4. A, 3. B multiplied by 4 becomes 12. C multiplied by 4, 4 get cancelled. and D 4. I think we cannot simplify it further, so we should keep it as it is. A 3, B 12, C 11, B 4 is the form. Right. So this is third question. Now, first was homework, 2 I have solved. I will give 2 situations here, and let that 2 situations be homework for you, because I really want to know how much you are understanding this. So situation D I am talking about, where all atoms, if all atoms present on one face are removed, and E will be if all atoms along face diagonal, if all atoms along face diagonal is removed, and E, that is BC we have solved, D is homework, E is also homework, and where I should have, there is no place here, so I write F here, remember E here and F here. If all atoms along body diagonal, if all atoms along body diagonal is removed. In last class we made one table. If face diagonal is removed, from which location how many atoms are removed? When body diagonal is removed, from which location how many atoms are removed? So we make the table like this and get this type of formula correctly. So this is also homework for you. I sincerely hope that you will solve this homework, because once you solve this, you will have better control on the MCQs, isn't it? Because the MCQs are clearly from this part. In theory also it can be asked. So practice it. So thank you for watching this video.